Okay.
I'm doing number 17.
Okay. Let's take a look. Let me pull this out. Pull out the 4.1. All right. So homework. Here we are. What are they asking us to do? Let me pull this up so I can share the screen here. All righty. 17, you said, huh? Let's take a
Yes.
look. See. Okay, yeah. In 2010, in the United States, there were 49,904,000 people not covered by health insurance. The numbers of those not covered in selected states are shown below. Numbers are in thousands. That's important. That's in thousands, okay? This is
Mm-hmm.
a whole number here. So that's part of the problem. It says choose a person not covered by health insurance, okay? What is
Uh-huh.
the probability that the person is from California or Texas? Okay, now the thing about it is that this number 49,904,000, that's a whole number. That's not in thousands. That's the entire number. These numbers are in thousands. So if you're going to actually use the numbers, you have to make sure that you either think of this as being multiplied by 1,000, or you take a factor of 1,000 off of the total. So here it says, what is the probability that the person is from California or Texas? Well, we know that California has 7,209 and Texas has 6,181. So California has 7,209, but that's thousands. So that really means that if I multiply this by 1,000, this is really how many people we're looking at in California total.
Hmm.
Because that means, see, there's 7,209,000 people. So you're multiplying this by 1,000 when you get there. And
And do we do the
Texas,
same thing for Texas?
right? Texas has, was it 3,181? Is that what I read? Let me see. Um,
I could check. I have the paper with me.
Texas has
Uh,
6,181.
yeah.
Okay, so here 6,181, and then we have to think about the probability of the whole group. So Texas has 6,181, and I'm going to do the same thing. I'm going to multiply it by 1,000. So I'm really looking at this many people,
Uh-huh.
6,181,000. Now, those are the people that are not insured in those two states. So remember, to get the probability of being not insured
Okay.
in California or Texas, right? We're going to have to look at the number of people. So if I'm looking at the probability formula we've been studying in the section for now, we're going to have to look at the number of people that are not insured in both states, right? Or I guess I should say in either state, because you're not going to live in two states at once, right? divided by the total number that aren't insured at all, which they give us. That's that 49 million number, right? So we're going to divide that by the number that's not insured, the number of total uninsured people, right, in the US. So here, we're going to add up these two numbers, the ones you see on the whiteboard, 7,209,000 and 6,181,000. You're going to divide that by the total that are not insured in the US. And we're going to get a decimal for that. Now, it might be easier. I don't know if let's see if the calculator will actually take it. We might have to use some scientific notation. Let me write the number. 7 million. Then I'll put it in 7 million. Okay, there we go. 7,209,000 and 6,181. And our total is 49 million something. Total is 49,904,000. 49,904,000. And 900, okay, 49,904. All right, so now we're gonna go and we're gonna grab the calculator here. And so we're gonna add up. So there's the calculator. Opening. Here we are. Let me share the screen here. So we have, clear this out. Okay. We have 7,209,000. 123 plus 6,181,123. That gives us a total of this. Divided by our total number, which is 49,904,123, right? And there we go. And that's about, if I want to make it a percentage, I can say 26.83%. Should be my answer there. Let me make sure that my captions are on. So,
17.
I think there's a second part also to that question, is there not? Okay.
Hold on 1 second.
Mm-hmm.
Got the first one.
Okay, so let's look now. I believe that we have a second part to this problem, if I remember. Choose a part. Okay, what is the probability that they're from? What is the probability that the person is not from one of these four listed states? Okay, so here, okay, so here we're going to work with what we call the complement, and we had some semblance of this in one of the other problems that we did. So we're essentially looking for, it's easier to think about what we don't want and then subtract what we don't want from one to be left over. Okay, so it says, what is the probability that the person is not from one of these four listed states? So let's figure out, let's add up all four of these and do the same thing, and then let's subtract that probability from one. We're going to use the complement idea. So I have two of them written down. Let me get Florida. 3854 is Florida. And New York is 2886. So this is Florida. And 2886 is New York. So here, what I'm going to do here is I'm
All
going
four of them?
to say, yeah, add them all up. And so here I'm going to do this. I'm going to say, get my screen. We're going to do all four of these. So we have 7209. I'm just going to multiply my answer by 1,000 at the end, rather than do each individually, plus 3854 plus 6181 plus 2,886. Okay, now I have to get the actual number, I have to multiply this by 1,000. So I'm going to grab this number and multiply it by 1,000. This is the people who are not covered. This is total, who are not covered in those four states. Okay. Now I'm going to divide that by the number that they gave me, which, if you remember, was, let me come back to it up here, was 49,009. Let me go here. 49,904,000, right? So I'm going to say 49,904,000. 904,000. That gives me this percentage. Now this percentage is the percentage in those four states, okay? But it said, what is the probability that they're not from one of those four states? Well, either they are or they aren't. So if you remember from what we were doing the other day, right? We're going to use kind of like that problem about when it rained, remember? Either it rains or it doesn't. And so those probabilities have to add up to 1 or 100. So all I'm going to do here is I'm going to take, since I have the decimal here, I'm going to use 1 minus this answer. And so the probability that you are, that you don't carry insurance and you live in a state other than one of the four that's listed is about 59.9%. 0.5966. If I want to make this a percentage, I can again multiply by 100 if I choose. And so it would be about 59.66%, depending on how you want to state the answer there. The trick there is the way the units are, because they're not all in the same, they're not all single people. That was the trick there, more than the probability rule.
Mm-hmm.
Okay.
Yep.
All right. Let's see. How are you with the next one? Number, I
The
think.
trigrams, I feel like I need more practice with those.
Yeah, well, we'll have more, we'll be seeing those again. And in more chapters. They take some practice, I don't doubt it. A box contains a $1 bill, a $5 bill, a $10 bill, and a 20. A bill is selected at random and is not replaced. Okay, this not replaced is important because that means that that bill can repeat then, because what happens is you pull it out and then you put it back. So those denominations can repeat. Then a second bill is selected at random. Draw a tree diagram and determine the sample space. Notice here, they don't ask you, they could, but they don't ask you for any probabilities. They're just asking you for all of the possible outcomes, okay?
Mm-hmm.
So let me do this here. So this says we have a 1, a 5, a 10, and a 20. So here we're going to all right, let's go over here. Get out of this one. This is number 18. All right, so again, when you're doing tree diagrams, the thing about tree diagrams, and this, like I said, they take some practice, but leave yourself some space. You want to make sure you leave enough space, because as you draw it, it's going to expand. If you do it from the top down, it's going to expand across the bottom of the page. If you do it on the side, like I do from left to right, it's going to expand vertically. It's going to expand up and down the page for you. So here, we're going to make a first choice. And we're going to use a dot to anchor ourselves, okay? And off of that dot, how many choices do you have?
4.
You have 4. So you're going to make 4 branches. Now, sometimes what some people do is they make 2 and then they make another one in the middle here. Sometimes you can, however you want to do it, like you try to make them so that you can see all of the options, okay? Then you're gonna, so this is gonna be your first draw, okay? This is your first draw here. Now, what can you draw? Well, you can draw a $1 bill. So we're gonna put $1 out here, $5 here. Oops. $5 here, a $10 here, and a 20. This is a 20. So then, now, because we put this back, this is where this comes in when you draw this. Because we replaced the bill, The fact I drew a $1 bill the first time means that okay, so here's my second draw. So I'm gonna put my second dot there, and I have a dot there, and I have a dot there. And I'm gonna have to, yeah, this is where this gets a little bit, because this needs to be out further, but I'm gonna pretend, okay? So this here, I'm gonna need 4 branches for this, because I have 4 options for each one, okay? So I have 4 options for each one of these. And again, they're the same, 1, 5, 10, and 20 off of each. And so when I create the sample space, it's about what options I have on each draw, but each little flower has 4 little options, okay? And so you get, I think I might have a better picture of this in my archives, but basically this is one, oops. Let me move this out of the way, because my this is 1, this is 5, this is 10. So this is my $1, my $5, right? My $10 and my 20. And I do that for all of these branches. So there's my $10 here. And my 20 here, and then so on. I have my $1 here, my $5, my $10, and my 20. Then I have my $1. That 20 goes with this. Then I'm gonna have to move that, because that is not gonna be, this is gonna be in the way. Okay, so this is gonna be my this is gonna be my $1 here. So I have my $1. Oops. My $5. My $10. My 20. And then down here, I have one final set. I have my $1 here. My $10 here. Oh, sorry, my $5 here. My $10. My $10. And my 20. So this is where, that's how my tree looks. Now, in terms of my sample space involves following the branches. So this one says I drew $1 and then $1. So I can do, when I do my sample space, I have you're gonna do, this is gonna be $1 and $1, because I could redraw $1, right? I could have my $1 with my $5 next. So this is my $5. Then I have my $1 and my $10 and my $1 and my $20. Then I have I could do my $5 would be next. So I have my $5 and I repeat them all. So this is my $5. And then I could draw my $1 after that. All right, so my $5 and my $1. And then I could draw my $5 and my $5, right? So here's $5 and $5. Once you see the pattern, it's just about writing them out. But this is how the tree diagram can help you. And we normally would go on to find probabilities with these, but right now we're trying to learn how to draw them. So this is $5 and $10. And
I think I'm
then,
trying to get it. The thing,
okay,
it's basically all numbers by 1, 5, 10, and 20.
yeah. So there's gonna end up being 20 outcomes in the sample. $1, $1, $1, $5. Let me see if I have the actual, hold on. Give me a moment to, I'm gonna, well, you're working on it, but it's not that difficult once you see what the actual pattern is. It's getting the pattern that's hard. Finding the pattern is the difficult part. Let me see, which number was that? Was that this?
Oh yeah, the pattern.
I think, oh no, this was the boy girl. 1. Okay, that was number 5. This is number 18. Let's see, 13. We did that. I'm looking for just the one. Okay, yeah, here it is. Let me download this and show you that this is a better picture of the tree diagram that I was trying to draw. Let me share screen here so we can see it. If I can get all of this, all my goodies to cooperate. There we go. Here's a picture of what that looks like. $1, $5, $10, $20. And then here's all your outcomes at the end.
Oh, that looks easy.
It's not particular. You use tree diagrams when you have sequential choices to make. So there's certain ways to make the first choice, and then there's certain ways to make the second choice. The reason here is that these are, now the difference here is that the difference in this one is it's not replaced. So she only has 3. We have an extra one on each of these because in ours it is replaced.
Oh, so that means there's 1, 1.
Right. There's an extra piece to this, to each one, because this is not replaced. That's the difference. But otherwise, the diagram looks, notice how I have it, so it starts with 4, but hers only has 3 here on each one. Ours has 4 because there are there we're replacing it. So we have an extra set of outcomes here. So if I come back to where we were, but that's essentially the pattern for this one.
So was that the answer?
For now, if you didn't replace it, we're replacing it. So we have an extra set of, I haven't finished the options, but here's your diagram, right? 1, 5, 10, 20, 1, 5, 10, 20, 1, 5, 10, 20, all the way down, right? So your answer is actually going to be the diagram with the options listed. So this is, to finish this, I have 5 and 5
So
and 1, 5 and 5, 5 and 20. Yes.
I have a question. Okay, so on my paper, it says not replaced for 18.
Oh, it says not? Okay,
Yeah.
well, if it's not, then, because mine said that it was replaced, but if it's not, then you don't have, okay. If it's not replaced, then you don't have, hold on, I'm gonna have to. Okay, so if I didn't replace it, then that means that I'm gonna have to get rid of this line, not that line, hold on. Redo, undo. Okay. If I don't replace it, then I don't use the same digits. So like the $1 would only have the 5, the 10, and the 20 attached. The 5 would not have the 5 attached to it. It would only have the 1, the 10, and the 20 attached. So then that would mean that it would look like this. If you didn't replace it, then it would look like what I showed you.
Mm-hmm.
It would look like this.
If it was not replaced?
If it were not replaced, yes. Because not replaced means that you're not going to repeat, because if you draw the $1 out, right?
Mm-hmm.
You're not going to have the $1 to put back because it's already out, right? So you can only
Okay.
choose the 5, the 10, or the 20. That's the difference. That's the difference.
Okay.
So if you're not replacing it, these become, you still have 4 branches initially, but then you only have 3 off of each one.
Mm-hmm. Do they have an example like this for the notes?
We
Like
should.
a one that is replaced, not replaced?
Let me see. That's a good question. Let me check. I believe so, but let me look
Because
for the
because
PowerPoint for that.
if not, I feel like a lot of other kids are gonna get confused.
No, I agree. And it takes practice, and that's why I think in this section, that's why she assigned so many problems. And that's why this chapter goes on for like 6 days. The chapter, not the section, but the chapter, because it's a lot of material. Let me check the PowerPoints because I do have them out, but I don't have them memorized. So let me stop sharing here and see what the PowerPoints tell me. 4.1. Because I know there's additional examples in the next section that relate to some of our other rules. Let me take a look. Okay. Complement of an event, we have examples of that one. Empirical rule, we have examples of that one. She, not in, okay, not in this. In this section, she only gives one example of the tree
Mm.
diagram. Okay, because she already had 31 slides. I'm pretty sure that there's examples in 4.2, but let me look into that. And if not, let me let her know. But I'm sure there are. But in 4.1, there's only one tree diagram. We do
And
additional, huh?
does it say replace or not replace?
It's the one about the boat and the subway. So you wouldn't, the example that I'm referring to is, let me see, where did I put it? There it is. Open this up. The example that I'm referring to has to do with, yeah, in this case, you could take, let me pull up the slides that I'm talking about, which I have them here, but let me make sure that I'm sharing them on the screen. In this example here, the question, which is on the slide previous, says, suppose a salesperson can travel from New York to Pittsburgh by plane, train, or bus, and from Pittsburgh to Cincinnati by bus, boat, or automobile. So some of them are repeated, like bus is repeated, right? But in this case, it's more about how you make the choices. So New York to Pittsburgh is plane, train, or bus. And Pittsburgh to Cincinnati is bus, boat, or automobile. So here, New York, you leave New York, you can leave New York by plane, train, or bus. When you get to Pittsburgh, you can travel by bus, boat, or automobile.
Mm.
So in that case, but you're right, I agree that we should have more. I think, as I'm pretty sure there are more examples in 4.2, but I will ask her that. That's a good question. Are
Yeah,
you in the online class or the
online.
you're in the online class? Okay. Yeah, I know that she's behind teaching it in the classroom, so I think she just taught it recently, so I'll ask her about that and see. But I'm pretty sure, let me take a look at 4.2, because that's one of the things that we get into more. 4.1 introduces a lot of stuff that is then expanded on in other sections. So not that we don't talk about it in this section, but it's expanded on in a lot of other sections. And I think we do have some tree diagrams. I know we have, see, the cards come back. I'm just scrolling through. The dice come back. No, okay. I'll have to bring that to her attention because I'm not sure she's aware. They're in the homework, but I'm not sure she's aware that there aren't more, unless she put more in the video lesson, which I haven't. The video lessons that I did, I haven't done video lessons for 4.2 yet, but unless she put more in the actual video lesson, I'll see. But we can certainly go over some of that. Let me show you the next one. The next one is another tree diagram, isn't it?
Mm-hmm.
The next one is another one.
Is 18.
Let me take a look. Whoops. Yeah, I need to make sure I'm on the homework, not the, I've got like, okay, 18. 19.
I mean, 19.
4 balls numbered 1 through 4 are placed in a box. A ball is selected at random and its number is noted, then it is replaced. Okay. A second ball selected at random and its number is noted, draw a tree diagram and determine the sample space. Okay. So the first choice we're making is selecting the first ball, essentially, right? 1, 2, 3,
Mhm.
4. And this one is, this one says replace. Okay, at least on my screen, says replaced on 19, right? It is replaced.
Mhm.
The second ball selected at random. So in this case, they would be repeated.
So if
So
it's
then,
replaced, they'll be repeating?
yes,
Okay.
because you're putting what's happening is you're you're doing this, you're taking a number and you're pulling it out. And then you're replacing it.
And you said for 20 again? Because
20.
yeah.
20 is first year students at a particular college must take one English class, one class in mathematics, a first year seminar, and an elective. Okay, so there's 4 kinds of classes. There are 2 English classes to choose from, 3 mathematics classes, 5 electives, and everyone takes the first year seminar. Okay, let me do something here. Let me go to, hold on, give me a minute to switch my screens. And I'm going to, okay, that was number,
20.
so now, yeah, let me just, okay, this one here, let me download it. Let me download that. And let me also download the next one, which is, okay, which is here. So I can show you this. So here is what 20 looks like. This has, it's a different number, but it's the same. Let me pull up the screen share so I can show you what this looks like. So here is what 20 looks like. So first year students, here's our screen share. I mean, our tree diagram for that. So they have a lot of choices in this particular instance. They have to take an English class. They have to take a math class, a seminar, and an elective. So what she does is she says, all right, well, I have an English class, a math class, and my elective, right? And I have my seminar because everybody takes the same seminar, right? So essentially what's happening is you're going to have,
So seminar means replace then?
no, it's just a different kind of class that you have.
Oh.
So you have one English class, so here's how your schedule looks. Let's think about the notes here. So this is, think about your schedule. So this is going to be, you're going to have, before you make the tree diagram for this, look at what you have. You have 4 classes. You have one English class, right? One math class. You have one elective and one first year seminar, which is, think of that as like an orientation or like a homeroom kind of class. That's what, like a first year experience class would be. That's what this is. So you've got, everybody takes this kind of same skill. Now, everybody takes the same first year seminar. So everybody takes this class. So there's only one choice for this class. Everybody takes the seminar. Okay.
Mm-hmm.
But when you get to English, math, and electives, you have options. Okay. So when you draw this out, you're going to have an English class. So you're going to have your English class, and you're going to have options coming off of your English class, however many there are, right?
Mm-hmm.
And then you're going to have another option. You're going to have a math class down here, right? And you're going to have options for that math class, right? And you're going to have an elective. You're going to have options for that elective class. Because not everybody's going to take the same elective. Maybe some people will take a sport, some people will take like a fine arts class, whatever it might be. But they'll have some kind of an elective over here, right? Everybody takes the same seminar class. So this is like your seminar class. Everybody takes this class. So when I do my diagram, right? My diagram is going to have, there's going to be 4 branches off of this idea, right? But this seminar class isn't going to have anything coming off of it because everybody's going to take the seminar. But there's like 2 English classes, so there's going to be 2 coming off of this English. And I think there's like 5 math classes. So there's going to be 5 maths coming off of this. So when you do your tree diagram here, when you do your tree diagram, you have your math classes. Notice there were 3. There were 3 math classes, right?
Mm-hmm.
There were 2 English classes. So down here, there's 2 English. You see how we have English and we have 2 coming off of that?
Yeah.
And then we have our 3 math classes and our electives, right? Our first year seminar, everybody takes. So everybody takes the same first year seminar. So I could put a branch out here to show that everybody takes the seminar class, because everybody's going to have this. The difference in their schedule is going to be these 3. Are you going to have English, math, and like the first English class, the first math, and the first elective? Or are you going to have this first English class, the second math class, and the first elective? You know what I mean? Because everybody's going to take it.
Yeah.
That's kind of where this is going. That's kind of how all of that is repeated. So that's how this comes out. Let me see if she happens to be available.
So that's what it's gonna look like.
That's essentially, except for the seminar, because everybody takes the seminar. So essentially there would be another branch out here, but there's really no reason to have it because everybody takes the seminar class.
Okay.
But I will, I'll mention that to her, and I'll see if I can send you this, Jason, so you can study it, okay?
Yeah, just in case for the quiz.
I think the quiz usually involves like boys and girls or something from the, so remember the family with 3 children that we studied?
Yes.
I would look at that one, because she tends to use that one quite a lot. The boys and girls with the with however many children. Sometimes it's 3 children in a family, sometimes it's 4, but it'll be something. I don't think it'll be this particular one, because this one is a little bit unruly,
Tricky.
just because it has so many branches to it.
Would
But
would something similar like this also be on like the exam coming up? Because I know the exam is in like probably 2 weeks.
well, if you look
or
at the review, there's probably some tree diagrams on the review, but I don't think they go out this many layers.
Mm,
Look at the review for exam 1, which I believe is up. And then and you'll be able to see it, but there will be chances for you to practice that, and there will be solutions available also for that. So but yeah, I will mention that to her, that we need to
oh,
have some more
examples.
examples of the tree diagrams. I'll mention that. We have time to work on it, so. And if I may I may get rigged into posting those, we'll see. But we do have tutoring again tomorrow, so we can I'll try to prep some and we can work on that when you come in, and then we'll do some stuff with 4.2. How are you doing with the cards and the dice?
Oh, I memorized it.
Oh, good. Good for you. Good for you.
Mm-hmm.
All righty. Well, I'm gonna have to leave it here, Jason.
All right.
But I will see you again very soon, okay?
Okay. Thank you for the help,
You're welcome. Thank you for
and
stopping by.
and have a good night.
You too. Bye now.
Goodbye.